Hi, in this class we will be talking about relief depiction and the various types in which we can depict the relief. So what is important here to understand is whenever you see an atlas or a globe, what do you see? You see blue color, you see green color, you see mountains, you can see rivers, you can see lakes. So what is all that? That is all we can achieve by means of relief depiction. So there are various strategies by which we can show what is present on the Earth's surface on the maps or on the globes. So let's understand the various forms by which we can see or share the relief features. So here are the various relief features. Let's start with the first relief feature. The first relief feature on the corner here is known as sugar loaves. So what is sugar loaves? So this is known as sugar loaves or hill shading. So under sugar loaves or hill shading, what happens is you give a side view or an oblique view for the region. It was mainly used in 1700s to find out or depict the mountain locations. It was not considered as that precise, so nowadays it's not used that frequently. So this was some of the most primitive techniques of depicting the relief on paper. Whatever you see on the earth on paper. So the next method is, this is known as hachures. In hachures, what you do, you draw parallel lines, and based on the width of the line and the length of the line, you can determine the level of slope. So it's basically these lines are drawn in the direction of the slope. So if the direction of the slope is here, the lines would be drawn in this way. Now, hachures are one of the popular means of relief depiction, but a major limitation is drawing so many lines. Let's see, for this small area will take a lot of time. So it is not that feasible to draw hachures, and the image that comes out, as you can see, is not of very good quality. It's poor and blurred in nature. So these are the two main drawbacks of hachures. The next method we use is contours. What is important in contours is you have a hill. I'll drop down the lines from the hill saying the height. So supposedly this is 0, 10, 20, 30, 40, 50, 60, 70 and 80. So this innermost point would be 80 and the outermost would be 10. So this is how you make circles around with contours. Contours are also known as isohypes or isolines. These are the popular names for the contours, as we know. Then in contours, as we can see, the hilltop is shown by means of loop. So this is known as rule of O. And if you are trying to draw a valley, the contours would emerge something like this, and these are known as rules of V. So these are the two common rules we follow while understanding the contours. Now another thing in contours is, let's understand the types. If the contour lines are parallel to one another, that means it's a uniform slope. If the lines are close at the hilltop and far thereafter, that means the hill slope is concave. If the lines are very closely drawn at the farther sections and very uh, distantly spaced towards the center, it would be the convex slope. So these are the three types of slopes we can understand here. Now similar to contour, there are two more features which are known as, one is form lines. So form lines you have similar to contour, the only difference is it would be drawn in a dotted manner. So you will have dash 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 instead of a smooth line. So these are known as form lines. And the next one is here is known as index lines or index contours. So index contours are much more thicker. So if a normal contour is this much, index contour would be this much. So that's the difference between a normal contour and an index contour. The next method we would be talking about is this here, which is known as hypsometric tint. hypsometric tint. What is meant by hypsometric tint is, under hypsometric tint, what you try to do is, you try to provide different colors to different elevations. So you can have green for forest, for example, here it's green. Then you can have dark brown for desert regions. So here it's dark brown. So basically it's color shading, and that color shading gives the idea of depth. Steep slopes are more darker in case of hypsometric tints. So this is one important aspect of the hypsometric tint. The next is spot heights and benchmarks. Now there are two things, spot heights and benchmarks. These can be seen on the contour maps. So what is the difference between the two? First of all, spot height is any mark on the any actual height above sea level which is marked by a cross and then the height 1570. Okay, so this is what is spot height. In case of benchmark, benchmarks are usually marked on the top of a building, and these are done by actual surveys. What is important in benchmark is benchmark forms a permanent mark for reference. So you can have a permanent reference at a building height, at the top of a building, and it will show you the height above sea level for that region. So that is the difference between benchmark and spot height, as you can see here. Benchmark is always written by BM. Then the next method here is hill shading. Hill shading is also known as relief shading. So basically what you are trying to do is, you are trying to shade the different aspects of the hill. So those regions in the hill which are close by would be more darker in color, and those which are less or steep down will be less dark in the color. So this is what is understood by relief shading or hill shading. And in hill shading, what is important is light source is always in the northwest and at a 45 degrees angle. So that is very important case in case of hill shading. So from where you will have the light falling onto it, based on that you can draw or shade the hill. So that is a black and white version, and that is a brownish version of hill shading. Now let's understand a similar term which shows slope analysis or slope maps. It's similar to hypsometric tint or hill shading, but here what we are trying to discuss is, we are trying to find out the slope. So the higher the slope, the darker would be the color. So the red or the pink color here shows the most dark regions of the slope, while the green area shows the less darker region of the slope, or the less steeper region of the slope. So slope maps are basically find out by explaining the slope of the various location, and the important thing here is the color gradient. Again, similar to hypsometric tint, but in hypsometric you are not only focusing on slope, you are focusing on overall features of the region. So that is what is slope map. The next we would be discussing is the block diagram. Block diagram is also known as perspective diagram. This block or perspective diagram is a three-dimensional mapping of any location on the earth. It is done by overlay grid method, which we have already discussed in the previous class. So basically you overlap two or three features one over the other. And this perspective is usually taken from an oblique angle. So I'm not seeing this block from front, I'm seeing it from an angle. That's why I can see this region. So it's an oblique view. These are the important things with regards to the major relief features. Now few other relief features that we would be discussing today are, for the another one is physiographic illustrations. In physiographic illustrations, what is important is, you would be talking about two things. First is hill shading, and the next is the relief shading. So basically you would be shading all the relief features along with the hills. So that is what is known as physiographic illustrations. The next method of relief depiction is elevation analysis. Elevation analysis can be done by two methods. First is hypsography. Under this, what you do is, you try to find out the elevation of solid angle which is relative to the mean level. So what we can do here is, this is the graph. This is the mean sea level. So I would be drawing from supposedly my Mount Everest. I would be drawing the figure here, and so this is the maximum height on the earth, and this is the maximum depth on the earth, and that everything I'm depicting on one single map or one single diagram, which is known as hypsography. And by this we try to find out the elevation of the solid surface relative to this mean sea level. The next is altimetric frequency curve. Altimetric frequency curve, what is important is you try to find out the height of the mountains. So what you are trying to do is you are trying to find out the height of the various mountains here. Now we would be talking about the most important section here, that is profiles. What are profiles and what is profile analysis? So for example, I have a hill here. Now, profile analysis means this hill, I am trying to cut a plain section on the ground and see what comes up. So basically this hill I am trying to represent it on the paper. This is supposedly 10, 20, 30, and this is 40. Okay, so now here would be the mark 40, 30, 20, and then you have 10. Similarly, you will go there. So this is what will be drawn on the paper. So this is what is known as a serial profile. Serial profile, the lines are usually parallel, and what you try to do is you try to draw one line and then other and show it on the map. Similarly would be drawn for this side. Now there are three more important profiles that we would be studying is, next is superimposed. What would happen in a superimposed profile? Supposedly there are 4 different mountains that we are talking about and I have to draw those. So this is the line for the first one. This is the line for the second one. This is the third. And this is the fourth. So all 4 would be drawn on a single sketch of paper and they would be overlapped one after the other. So that is what is superimposed. The next is what is known as composite. What would happen in composite is, let's understand the same diagram here. So what I would be doing is, I would be taking the only the topmost line. So this is blue, then there is a section on red, then there is a section on light blue, then there is a section on brown, and then finally again a section on red. So that is, I am just taking the topmost profiles of that region into consideration, and by that I can form the composite profile. This composite profile is also known as ruggedness of a skyline. As while seeing this, we can get a feeling of a skyline or something like which you can see beyond consideration. So that is projected profiles. What are projected profiles? Projected profiles are the most important to understand. Here is the case where most students get lost. So let me draw the first profile curve. So this is the first profile curve. Now what would happen is, I am drawing the next profile curve. Okay, this is my next profile curve. What would happen is, in the next profile curve, I'll have to remove the region which is below the first profile curve here. Got the point? Now, next is, for example, I am drawing this region. Okay, so whatever comes below the blue one, I'll have to remove it out. So I'll be removing this section. and then I'll be removing this section. And then finally, when I'm drawing the last line, let's consider this by green. So I would be drawing the last line. Now whatever is below the orange would be removed. So what is below the succeeding, I should say succeeding profile is omitted. So this would be removed, and again this section would be removed. So this is the final map that you will get into a projected profile. So these are the four very important profiles that we have understood today. First is the serial profile, superimposed profile, composite profile, and projected profile. So just to summarize what we have done today. In today's class, we have talked about contours, hachures, then hypsometric tints, block diagrams. We have talked about the profile analysis, the serial, composite, superimposed and projected profiles. We have talked about the elevations and the various methods of hill shading and slope analysis. So these are the various ways by which you can depict the relief features around, and these are the major methods that are used either in GIS techniques or while drawing any atlas or global locations on the globe, a three-dimensional picture. Hope you enjoyed this class. Have a good day ahead.